Okay, so now these are the exercise questions at the back of your textbook. Exercise 1.1, 1.2, 1.3, 1.4, 1.6. I've done exercise 1.5 recently. Now, let me start with, I think this is, let me see, exercise 1.6. Okay, which of the following has the same dimension as time? Okay, okay, go to your textbook. Yeah, go to your textbook, then open to the exercise. Go to exercise 1.6. They said, which one of the following has the same dimension as time? They said A equals to A x over A, then B root 2x over A, C root V over x, then V times x, then X A. Okay, so they're asking us which of these has the same dimension as time. That is, which one has, if you solve for the dimension of all these, which one will land, which one will be exactly t. Dimension of time is what? Capital letter T. So we are going to solve each of them to see which one will give us which one answer we just land exactly to be what? T. So let's start with E. Now, ox, which is, I told you guys that ox represent distance, okay? And what is the dimension for distance? Dimension for distance is capital letter L. Then what is dimension for times? What is dimension for acceleration? Dimension for acceleration is L t raised power minus 2. So based on the fact that L standing alone is the same thing as L1, okay? So yeah, same thing as L1. Yeah, it's same thing as L1. So according to indices, based on the fact that both of them are the same base, and since they are multiplying, we take one of the base, then we'll add the power together. 1 plus 1 give us 2, then times t. So this is the final dimension of this quantity. So does our final answer land to be t? No. So that shows that E is not correct. Okay. So let's check. Let's do this other one. D is what? Velocity times distance. And what is the dimension of velocity? Dimension of velocity is L t raised by minus 1. What is the dimension for times? What is the dimension for distance is what? Is L. So the same thing that happened now. Since both of them are the same base, we take one of them, we add their power together. So adding their power, we add L2, then times t minus 1. So this is dimension. So this one is not also correct. Okay. Yes. Then let's go to C. So C is what? Root velocity over x. Now what is the dimension of velocity? Is what? L t raised power minus 1. What is the dimension for distance? Is what? L. So based on the fact that these two are the same base, based on the fact that these two are the same base and they are dividing each other, we will take one of the base and subtract the power, because why? They are dividing. Since they are dividing each other, we take, and the both of them are the same base. We take one of the base and we subtract their power. 1 minus 1, we subtract the power, then times t raised by minus 1, then root. Okay? 1 minus 1 give us 0. So 0 raised by our L give us 1. 1 times 1 times t raised power minus 1 will still give us t raised power minus 1. So our answer will be what? Root t raised power minus 1. And we are looking for t, not root t raised power minus 1. So therefore this one is not also correct. Then let's check B. B. Now B is root. What is dimension times? What is dimension for distance? Dimension for distance is L. Then all over. What is dimension for acceleration? L t raised by minus 2. Okay. So we can either we can just cancel, or if we can cancel or do any other thing. Let's just continue. So okay, so and okay, I can cancel. Let me just go straight. Since both of them are the same base, I'm coming. Since both of them are the same base, we will take one of them, then we subtract the power. If we take one of them, then we subtract the power, 1 minus 1 will give us 0. So 0 raised to power L will give us 1. So everything here we cancel each other. Will give us 1, abi? Yes. Then what about 2 times 1 give us 2, then all over. Now t raised power minus 2. T raised power minus 2. Okay. Now root. Now t raised to power minus 2 is the same thing as I'm coming. Okay. Is the same thing as 1 over t raised to power 2. I don't know if you understand. According to indices, I told you guys that b raised power minus 2 is something as 1 over b square. Abi, yes. Now, t raised power minus 2 will be something as what? 1 over t square. Abi, yes. So, I can put, if I put 1 over t square here, this t will come up here. I don't know if you understand. This t will come up here. I don't know if you get. I said we landed when we landed to be here to be t raised power minus 2. And t raised power minus 2 is something as what? 1 over t raised power 2. Abi? Yes. Now if you place this in this very place, if you place this in this very place, this one based on the fact that it's fraction, you are placing another fraction at the bottom of another fraction. This place will come up. I don't understand. So here will now be 1, then this t square will now come up here. So times t raised power 2. I don't know if you understand. So so the square root now be 2 times t square all over 1. Anything dividing 1 will still give you that same thing. So it will now be 2t raised over 2. Then square root will cancel square. If square cancel square, we'll be left with what? 2t. Then remember, I told you guys that value does not have dimension. So therefore, these two neglect it. Our final answer will be what? Capital letter T. So this shows that B is the right one. Okay. So this shows that B is the right one. Okay. So let's move to exercise 1.4. Exercise 1.4. They said one student using unit analysis says that the equation v equals to root 2ax is dimensionally correct. Another says it is not. With whom do you agree? So is this formula dimensionally correct? How do you know if it's correct? The dimension in this place will also be the same as the dimension in this place. If the dimension in this place is not equal to this one, we know that this equation is not correct. So what is the dimension of velocity? Dimension of velocity is what? L t raised to power minus 1. Then equals to then root 2. Let's neglect 2. Neglecting the 2 because 2 is a value. What is the dimension for acceleration? The dimension for acceleration is L t raised to power minus 2. The dimension for distance is what? Capital letter L. So based on the fact that these two are the same base, we take one of them and we add their power together, then times t raised power minus 2. Adding these two together will give us L2. Okay? Give us L2. Then t raised power minus 2. Then all square. All then the square root then equals to LT. Okay? So okay, yeah. Now let's continue. Let's continue. Okay, so we landed as L square t raised power minus 2. Okay, now t raised power minus 2 is the same thing as what? Remember, I say guys, b raised power minus 2 is the same thing as 1 over b square. Abi, yes. So t raised to power minus 2 is the same thing as is the same thing as what? Is the same thing as 1 over t square. So all here will now be what? All here will now be times 1 over t square. Multiplying all this, we get root L square over t square. Okay, remember the dimension at this side is what? Is L is LT raised to power minus 1. Okay, dimension on this side is LT raised to power minus 1. Now we are solving for the dimension on this side. Now we are going to this point. Now the square root will cancel, the square root will cancel square. The square root will also cancel the square. We'll be left with what? L over T. So we'll be left with what? L over T. And L over T is the same thing as what? LT raised to power minus 1. So this equation is dimensionally correct. Okay. Yes, this equation is dimensionally correct. Now let's move to question 1.3. Okay, question 1.3. Question 1.3, they said, show that equation x equals to s naught, then plus vt. Show that equation x equals to s naught plus vt, where v is velocity, x and s naught is length. Show that this equation is dimensionally correct. How do you know if it's dimensionally correct? The dimension on this side will be the same as the dimension on this side. What is dimension on this side? Dimension for length is what? Or distance or displacement, anyone. Dimension for length is capital letter L. Now, what about this other plate? Now, dimension for length is also L. Then plus, what is dimension for velocity is L t raised to power minus 1. Dimension for time is what? Is t. So, since these two are the same base, we bring out one of the base, then we add the power together. So L minus 1 plus 1 will give us what? 0. So 0 raised to power anything raised to power 0 will give us 1. Abi? So therefore everything here will be what? Will be 1. 1 times L will give us L. Then L plus L will give us 2L. Okay? So 2L, remember, I always told you guys that value does not have dimension. Therefore, L equals to L. So therefore, this equation is dimensionally correct. Okay? Yeah, therefore this is dimensionally correct. Okay? Then which other one again? 1.2. 1.2. Okay, they said if x is equals to gt square all over 2, is it dimensionally correct? Okay, is it dimensionally correct? And what are they assigning it of? Constant G constant. Now, the author they still should look at whether this is dimensionally correct. Okay, how do you know if it's dimensionally correct? The dimension this side will equal the dimension on this side. Dimension this side is what? Capital letter L. What about this side? G is what? Is acceleration due to gravity. G is acceleration due to gravity. And what is acceleration? Where's the dimension for acceleration? Dimension for acceleration is L t raised by minus 2. Then times dimension for time is what? T. Remember, time is in square, so square. Now, based on the fact that these two are the same base, we'll bring out one of them and and they are multiplying, so we'll bring out one of them. We add what? We add their power minus 2 plus 2. Minus 2 plus 2 will give us what? Will give us 0. Abi give us 0. So anything raised to power 0 will give us 1. So therefore everything here will be what? Everything here will be what? Will be 1. 1 times L will give us what? Will still give us L equals to L. Remember, we are divided by 2, Abi. Now these 2, remember I told you guys, value does not have dimension. So therefore this is what dimensionally correct. And where is the SI in for G? Acceleration due to gravity has the same SI unit, is same thing as acceleration. So the dimension for the SI unit of G is 1 meter per second square. So the last part 1.1, exercise 1.1, they said you are told that the volume of a sphere to be V equals to pi d square all over 4. Okay, they say where V is the volume of where V is the volume where V is the volume and D is the diameter. They said, is the equation dimensionally correct? Now, so how do you know if whether this equation is dimensionally correct? They said this is volume, while this D is diameter. Now, they said the volume of a sphere is V equals to pi d square over 4. Now, normally, the volume of a sphere is 4 pi cube, 4 pi cube, arrow, okay, I'm coming, yeah, okay, 4 over, okay, arrow cube, if I'm not mistaken, yes, if I'm not mistaken. the volume of his sphere, the volume of his sphere, yeah, the volume of his sphere, I think is okay. Volume of his sphere is 4 pi. The actual volume of his sphere is 4. I mean, is V equals to 4 pi r cube all over 3. So this is the actual volume of his sphere. And they brought another equation out. They're asking us, is this equation correct? Is this correct? Is this the volume of his sphere? I don't understand. This is the actual volume of his sphere. Now they're asking us whether this is correct. So we have to prove. Let's prove that this is correct. If we prove that this is, let's prove. We need this is diameter, okay? While this one is radius. So we need to convert this one to radius. If we convert this one to radius, and we find out that when we converted it to radius, we solve and we get this exactly the same this formula, we will know that this equation is correct. I don't know if you understand. The volume of a sphere is 4 pi r cube all over 3. This is the actual volume of a sphere. Okay, yes. Now, they brought an equation out and they said volume is equals to pi d square over 4. And they are asking us, is this correct? Is this volume of a sphere? Now, let's turn this diameter to radius. If we turn this diameter to radius and we solve using the radius and we get the exactly the same formula as this, we know that this one is correct. But if we didn't get the same formula as this, we know that this one is not correct. Okay. So what d for diameter? And diameter is two of radius. Okay, yes. This is a full circle. From here to here is the radius. From here to here is the radius as well. From here to here is radius. From here to here is radius. The whole line that crosses the circle is what? Is the diameter. So diameter from here to here is radius. From here to here is radius. So diameter is what? Is 2 of radius. Okay. So diameter is 2 of radius. Whenever we see D, we'll put 2 arrow. Okay. So V is equals to pi. D is what? 2 arrow, then all square all over 4. Now, what is this? The square of 2 is what? 4. The square of arrow is arrow square. Then pi all over 4. This one cancel this. So this one is not correct. Okay, yes. So we replace the D with arrow. When we replace D with arrow, we solve. We didn't get the formula that we get was pi arrow square. And this is not the volume of what is fair. So this the number one answer is that this equation is not dimensionally correct. Okay.